This chapter, chapter 4, is going to be all about trigonometry, more than you ever wanted to know about trigonometry. So we're going to start with the basics, your sine, cos, tan. Hopefully you've heard the mnemonic at some point, so, ka, toa. So that's just sort of an old school trick that they've taught to remember the ratios. So first, just looking at the triangle on the left here, we have this little symbol that's called theta. It's just the super commonly used Greek, I believe, letter for angles, theta. It just looks sort of like a big O with a little scriptive line running through it. And so with regards to that theta, we have the three sides of a right angle triangle. The hypotenuse is always going to be opposite of the right angle. And then we have the other two sides. The opposite is always going to be opposite of your angle theta. So that means that it's not touching theta as far as the sides go. The hypotenuse should be touching theta, right? The hypotenuse is over here. It's touching that angle. And then the adjacent also will be touching the angle theta. The adjacent is the side that's touching theta that's not the hypotenuse. So those are our three sides. Adjacent does just mean beside, right? It's just another fancier word for beside. And so the SOHCAHTOA is coming from the fact that the sine of the angle is the ratio of opposite over hypotenuse. Cos is the ratio adjacent over hypotenuse, and tan is the ratio opposite over adjacent. And so what's nice about that is that you can have like two very different triangles with the exact same angle. So for example, if I just draw like a green line down here, I just have actually a smaller version of the same triangle, but proportionally it's all the same. And so these ratios only have to do with proportions, not actual quantities of those sides. They're just ratios between everything. Okay, so we're going to find sine, cos, and tan for each of these triangles. I did not write angles in them, so you can't actually answer it yet. So let's put some thetas in there. Let's do theta, theta, and theta. Okay, now we can answer these questions. Sine, cos, and tan. So what we need to do is figure out the opposite, adjacent, and hypotenuse for each of these. So hypotenuse is always going to be the one across from the right angle. So that's my hypotenuse. And then opposite of theta is opposite. And beside theta, it's not the hypotenuse, will be my adjacent. And so that should allow me to set each of these up. So sine theta is going to be the opposite over the hypotenuse. And I just take those numbers, 3 over 5. Cos theta is the adjacent over the hypotenuse. Take those numbers, 4 over 5. And tan theta is opposite over adjacent, that's my TOA, is 3 over 4. So that's it. Those are my ratios. And so for B, you'll notice that I don't have the hypotenuse figured out here. I do have my opposite and my adjacent, but we haven't got the hypotenuse. However, we can find the hypotenuse, right? It's a right angle triangle, so we do get to use the Pythagorean theorem. So h squared is going to be 5 squared plus 12 squared, right? The sum of the square of the hypotenuse is, the square of the hypotenuse is the sum of the square of the other two sides. And so if we add those together, that's 25 plus 144 is 169. And so I should get that h is 13. Right now, for this picture, it's just kind of a generic triangle, so we wouldn't want to have any negative sides in there. So we do just want the positive root, but don't take that for granted. It's going to be important to keep track of negatives soon enough. So we have h is 13, so we can set up all of our ratios. So sine theta, opposite over hypotenuse would be 12 over 13. Cos theta is adjacent over hypotenuse, 5 over 13. And tan theta is opposite over adjacent, 12 over 13. So this is called a Pythagorean triple. Just these three sides are all integers. It's not always going to be the case, but it is kind of a special nice one, and I can come up with lots of those for these questions so we don't have ugly roots. All right, the last one, same deal. We are missing a quantity, but again, I've got my hypotenuse. And I don't have my opposite, so we're gonna figure that out. And I do have my adjacent. But yeah, we can do that. It's gonna be a bit ugly because of these x's, but it's the same deal. So what I'm gonna have is my hypotenuse squared is equal to my adjacent squared plus my opposite squared. I'm going to use the whole OPP instead of just H because O looks like zeros. So I can set this up. I can square the x plus 5 squared. I should get a x squared plus 10x plus 25 equals x squared plus my opposite squared. I can subtract the x squared over and I'll cancel. So I've got 10x plus 25 is my opposite squared. And now all I can do is take that root. And again, I have to assume it's the positive root because this is just a pretty normal looking triangle. I wouldn't really have negative sides. But yeah, that's what I'm going to get for my opposite, this ugly root expression. But it should satisfy the Pythagorean theorem. And it lets me solve all of these questions. So sine theta is the opposite, that horrible root, 10x plus 25 over the hypotenuse, x plus 5. Cos theta is my adjacent, which is x, over hypotenuse, x plus 5. That one's not so bad. And tan theta is going to be my opposite, the root, 10x plus 25 over the adjacent x. So yeah, this is basically how we find these sides, and what this is going to do now is allow us to solve for different things in the triangles.